Hi, I'm Yifang from Clemson University. Today I'll be presenting our paper about the taxonomy of content sensitivity and sharing preferences for photos. Almost everyone uses an online social network. We present ourselves, communicate with our friends, family, or even strangers. People share a huge amount of data via online social network sites. For example, Facebook users upload 147,000 photos every minute. However, sharing photos increases the privacy concerns about the personal information contained in these photos. For instance, people may identify your family members in a group photo. And these two groups may lose their jobs if they share photos of consuming alcohol on their social network sites. Or it's just a photo that you really want to share, but you have concerns on your facial expression. In our prior work, we introduced two promising obfuscations to protect photo privacy. Avatar, which replaces a person with an avatar that hides the identity but preserves facial expression and gesture. And inpainting, which completely removes a person from an image. So both of these obfuscations we invented and studied overcome the trade-off between the effectiveness and the utility of an obfuscation. However, we only study these obfuscations for removing one kind of content, photos of people. But other content in photos may be sensitive too. To be able to obfuscate sensitive content in photos, we need clues about what things people consider sensitive. Some work in machine learning has investigated this, but it has a lot of problems. Machine learning approaches failed because they did not adopt a human-centered perspective. For instance, researchers used a public Flickr dataset that didn't contain users' most sensitive photos. They also used a binary classification, like private versus public, which we know does not fit with how people think about privacy. Perhaps not surprisingly, the results from this work ended up being way too broad. The researchers concluded that photos of the outdoors are considered public and photos taken indoors private. And the categorization is not only too broad, but also incorrect in many instances. A photo taken outdoors can very easily contain sensitive content that someone may want to keep private. We still don't know empirically what types of content people consider sensitive in photos. I've shown you a few examples, such as facial expressions, consuming alcohol. However, there might be more sensitive content that could cause privacy leakage that we may overlook. Second, people have different levels of privacy preference for various groups of photo recipients. We don't yet understand the variations in sharing preferences by recipient group. For example, I'd share a party photo with my close friends, but definitely not with colleagues. Here are the contributions of our work. We introduced a novel method to elicit sensitive content from participants. It removes many of the barriers in collecting private content by providing participants with alternative ways to identify sensitive content that preserve their privacy. And we conducted two studies. In study 1, we collected photos that contain sensitive content from participants. And in study 2, we conducted an in-person card sorting to group the 181 unique pieces of raw sensitive content into 28 categories and generated a taxonomy. In study 1, we conducted a survey and collected photos or descriptions of photos with sensitive content from 116 mTurk participants. And we collected 5 photos from each participant. This is what participants saw during the survey. First, they were asked to identify a photo that they consider private. The barrier in this kind of studies is that participants are not willing to share sensitive photos with researchers. But we introduced a novel method that we provided participants 3 options. First, we asked them if they were willing to share this photo with us. If they answered yes, they were then guided to the next page to upload this photo. If they answered no, they would see this page where we gave them the other 2 options. They could look for an online photo which has similar sensitive content or describe the photo in detailed text. And afterward, we asked participants to tell us a piece of content that you consider most sensitive in this photo. Following with the first private photo, participants then identify the other 4 photos that they would not want to share with their family, friends, colleagues, or classmates, and acquaintances. This pie chart shows our sensitive content data points. In total, we collected 563 pieces of sensitive content, and 329 were their personal photos, 216 were similar online photos, and 18 were text descriptions. From these, 181 were unique pieces of sensitive content. I want to show examples of the kinds of personal photos that participants shared with us. But I don't want to violate the privacy of our participants, so I'm going to show you the similar online photos that they provided, and also the text descriptions that they provided. So here are the online photos that they provided, for example, smoking illegal substance, unhealthy eating, or on the toilet. If participants didn't want to share the photo they identified as sensitive, we asked them to provide a text description. For instance, here, a picture of my wife laying on the bed. Allowing people to share in the way they are comfortable is one of the methodological innovations we describe in the full paper. Here's a summary of Study 1. We ended up with a total of 563 pieces of content and 181 unique pieces of sensitive content. Unique here means that they are not repetitive. But 181 is still too big to be useful to designers. So in the next study, we conducted cut sorting studies to group the content into categories. In Study 2 cut sorting, we recruited 14 participants. We asked them to group cards that have similar content using XSort. This is how we group the individual items into categories. We created a dendrogram based on participants' categorization. Using a higher breakpoint would have fewer categories which might be too broad, while a lower breakpoint would generate 2 more categories. So we break it at 0.8 to generate reasonable number of categories. So in total, we have 28 categories. Here are some examples of the highest level categories. First one, people avoid sharing photos that contain nudity or sexual content. And they are not willing to share photos that depict they are irresponsible to children or pets. They don't want to share their unflattering facial expression with others. Or photos show that they behave unprofessionally at work. Or any visible blood or medical conditions. And the ones show that they are related to LGBTQ. And other people's information. The example here is a to-do list that belongs to your participant's friend. Though to-do list itself might not be sensitive, people consider it sensitive if it's others' information. This is a table from our paper. The text looks very small here, and I'm not expecting you to be able to read during this presentation. What I want to show you is what the table that we generated looks like, and let you know to look for it in the paper. The table contains the categories of sensitive content we identified, along with many examples from each category. Besides the taxonomy, we also investigated people's sharing preferences with different recipient groups. This is a bar chart of likelihood to share each sensitive content category across all recipient groups on the 7-point Likert scale. It shows that people are least likely to share other people's information, which means they generally respect others' privacy. Also, they are not likely to share medical treatment, sleep and grooming, and nudity or sexual content with others. Oppositely, they are not extremely worried about sharing photos that have bad quality or the ones depict personal assets for other people. But we know that for all categories, the ratings are below 4, which means they are generally sensitive to participants. This chart shows the likelihood to share with each recipient across all sensitive content categories. We can see that people are most likely to share sensitive content with their significant others, which rating is slightly above 4. But they are not likely to share with colleagues, people that they are not very familiar with, such as friends of friends. Besides the overall plots, we also explored if there were interactions between the sensitive content categories and recipients. We were looking for sensitive content categories that do not follow the general trend. For example, we noticed that people are more likely to share photos that depict when they are unprofessional at work with their close friends and significant others compared with all other recipients. Here's the usage scenario of our findings. We could build a photo sharing feature like this on social network sites. After uploading a photo, the system will automatically detect the sensitive content. In this photo, there are a beer can, 3 people's faces. So here I choose to obfuscate the beer can, and then the system asks which obfuscation I'd like to apply. And I choose inpenning. You can see that the beer can is removed from the photo. We could also have a recipient suggestion feature. For instance, it suggests me not to share this photo with colleagues and acquaintances, so I can properly select the recipients. Acknowledgements. So we would like to thank National Science Foundation for supporting this research, and we thank Dr. Bart Landenberg and colleagues from our head lab for all the suggestions that improve the study. We're also grateful to the CHI reviewers and all the participants of our study. If you have any questions, feel free to reach out to me at this email address. Thank you.